Now that we've seen how to define classes in Scala, I want to introduce how to define singleton objects. Now we've actually done one already. Our calculator was a singleton object. We just said object calculator. I'm not going to talk about what that means just yet. Let's just play with the concept a little bit first. What I'd like to do is take the cookbook class that we have and make an object cookbook instead. Now, there's nothing wrong with the cookbook class that we have, by the way. This cookbook class is actually more flexible than a singleton object is, of course. We're just going to do this for fun. So let's go ahead and delete cookbook and just declare it as an object instead. We can say object cookbook. And I'm just going to paste in here some recipes that I've declared previously. So I'll paste in a peanut butter and jelly sandwich recipe and a bacon pancakes recipe. And if you're following along, you don't have to type all this out. I just want to show how this works. So let's save this and go back over to the console. I'll do my import like we had before. And now that I've declared cookbook as a singleton object, I can just refer to it directly. Now something interesting is going to happen here. When I refer to cookbook for the first time, it's actually going to initialize its fields. And you can see that happening because in the constructor for recipe, we have these print line statements. If I refer to cookbook the second time, of course this doesn't happen. It's not going to reinitialize the fields over again. So let's say cookbook.pbj. All right, so that gives us a reference to a recipe. And we can confirm that that actually is the recipe that we want. We can do the same with bacon pancakes. Okay, so really when we talk about singleton objects, that's exactly what we mean. There's an object that you can refer to directly by its name, cookbook, and you can access its fields. Well, we haven't said the cookbook is an instance of class cookbook or anything like that. We haven't declared a class cookbook. We've only declared object cookbook. If I ask the interpreter, what's the type of cookbook? It'll tell us cookbook.type, which is sort of odd. This is something called a singleton type. Again, a singleton object is constructed and its fields are populated the first time it's referenced, as we saw. And that's really all that there is to it. So why did we do that for calculator? Well, the reason why we had to do that for calculator is because calculator had a main method. So let's think about that for a moment. In Java, the main method is usually declared as static. You wouldn't call main on any particular instance of the calculator class. You would just say calculator.main. And that's exactly what that means here. As a matter of fact, when Scala is compiled, the methods and the fields that belong to our objects are actually compiled down to static methods and static fields in the Java bytecode. So that raises the question of whether it's possible to define a class that has both instance members and static members. And the answer is yes. The way that we do this is just by defining both. We can define a class recipe, and we can define an object recipe. The recipe class contains all the instance members, and the recipe object contains essentially all the static members. So one common use for static methods is to implement factories. So we can implement a factory method for recipes, for example. We can say def make, and it'll take the same things that the recipe constructor does. So we can say make will take ingredients of type list of string, and directions of type list of string. It'll produce a recipe, and all that this needs to do is just call the constructor. We say that the class recipe and the object recipe here are companions. And that's, of course, because they have the same name. But the other thing that's important here is that also they have to be declared in the same file. If they're declared in different files, the Scala compiler won't know that they're companions. Another thing that's important to point out about companions is that access control isn't affected by the fact that these appear to be different entities. So for example, if one of my fields in recipe were private or protected, the recipe companion object could still see it. And likewise, if any of the members of an object are private or protected, instances of the class can still see them. So just to demonstrate something, let's make the constructor for recipes private. Now we're not going to make the class private, we're going to make the constructor private, and that looks like this. This is actually very common when you implement factories, right? You want the factory to be the only way that you can construct an object. So now that we've made the constructor private, and instead exposed this factory method called make, what we have to do is say recipe.make. And recipe.make over here as well. The last thing that I want to point out here is that although object recipe and class recipe are companions and they're closely related, the recipe object, if I refer to it, isn't an instance of class recipe. So let's go back to the console again. Let's get the type of recipe. That's going to be the type of the companion object, which will be the singleton type. And now let's get the type of, let's say, cookbook.pbj. That's the recipe class type, not the singleton object type. If I try to say recipe.ingredients, well, that won't work. Ingredients isn't a member of the recipe companion object. Ingredients only belongs to instances of the class recipe. Likewise, if we try to use a recipe class instance as though it were the companion object, that won't work either. So for example, let's try to use cookbook.pbj to make a new instance of the recipe class. So that won't work either, because make doesn't belong to the recipe class, it belongs to the recipe object. And this is Scala's way of maintaining a clear distinction between static and instance members. In Java, you can get yourself into trouble sometimes by referring to a static member as though it were an instance member. In Scala, there's no way to accidentally do that. The last thing that I want to mention in this sublesson is not necessarily directly related to singleton objects, but it comes up fairly frequently in that context. And that is the notion that any stable identifier can be imported. What do we mean by a stable identifier? An identifier is a name. So for example, cookbook.pbj. That's an identifier. And what we mean by stable is that the identifier points to something fixed. PBJ can't refer to any object other than the one that it currently points to. So we can import cookbook.pbj and refer to it without having to prefix it. Just to take this to its logical conclusion, we can also import the fields of PBJ itself, because those are stable as well. So I can say import pbj dot, let's say everything, and now I can just refer to ingredients and directions. This isn't something that you want to overuse, but it's handy from time to time. The important thing to note here is that an import statement can actually appear anywhere inside your source code, anywhere you'd like to bring a qualified name into local scope. That's different from Java, of course. In Java, your import statements can only appear at the top of your file. So that's about it. We saw objects and we saw companion objects, and we talked about how you can import fields or method names from within objects. In the next sublesson, we're going to learn about some common uses for objects.